Let's take a look at problem number 38. Now there's three different ways you could work this one. You could work it as dividing two rational expressions, or it's a complex rational expression. And then there's two different ways of working that. I want to work it with the steps I show that works 100% of the time. And it's these here. Simplifying complex rational expressions. You want to factor all your inner denominators. Figure out the LCM of all the inner denominators, multiply everything by them, factor the top, factor the bottom, and cancel if possible. Let's see how those steps apply to this problem. Okay, so we got x squared. That's interesting. Got a little tear on my paper. Okay, come down here. X squared minus 18x plus 81 over negative 12x all over x minus 9 over negative 2x. Okay, now when I'm talking about the inner denominators, I'm talking about this one and this one. So factor all your inner denominators. There's nothing really to factor here. I mean, I suppose you could do the numbers, and those steps would kind of flow also, but it's pretty simple, so we don't have to do that. Figure out the LCM of all your inner denominators, multiply everything by them. Well, they both have a negative, so I'm going to have a negative. If I look in 12 and 2, my LCM there, least common multiple, would be 12. Because actually, 2 divides into 12. And for the x's, I'm looking for the greatest number of x's in a single inner denominator. There's one here, so we'd have 1x. So that's what we multiply everything by. So multiply times the x squared minus 18x plus 81 over negative 12x. And we'll also multiply it by the fraction on the bottom, the x minus 9 over negative 2x. Well, negative 2x's, or negative 12x's cancel there. Down below here, the x's is going to cancel. The negatives will cancel. And I'm left with 2 and 12, which are both divisible by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. So I'm going to have, up on top, I'm left with x squared minus 18x plus 81 over, on the bottom, we have 6 times x minus 9. Now I don't want to actually multiply that through, because our next step is to factor the top and factor the bottom. Well, this top part is the PSD method. X squared, x, no x, and there's no number for x squared. With the PSD, let me do it over here on the side so we see the steps. Now it doesn't mean it'll actually work, we're just trying it. We take the number at the end, the 81, and we're going to come up with 3 columns. Our product column, we list all the products to give us 81. 1 times 81, 3 times 27, 4, no, 5, no, 6, no, 7, no, 8, 9, I guess. 9 times 9. In the sum column, we add those together. 1 plus 81 is 82. 3 plus 27 is 30. 9 plus 9 gives us 18. In the difference column, we subtract them. 81 minus 1 gives us 80. 27 minus 3 is 24. And 9 minus 9 is 0. Now the number we're looking for is the number in our middle term, which is 18, which is right there. So we use 9 and 9. Now our larger number in the P column, which are both the same, so it doesn't matter which one you choose, but a larger number, which is 9, is going to be the same sign as the middle term always. So the middle term is negative, so it'll be negative. If the number you circled is in the S column, S for same signs, which means they'll both be positive, both negative. Since this one's negative, then this one has to be negative. And that's how it factors. So I got x minus 9 times x minus 9 over 6 times x minus 9. That's factor the top, factor the bottom. Cancel if possible. Well, notice here I have an x minus 9, here I have an x minus 9, so those are going to cancel. And we end up with x minus 9 over 6. X minus 9 over 6 looks like a B is in Bill. So let's go verify that. 38B. And that checks. Now, one thing we'll mention, the other way to solve a complex rational expression is to, if you got a single fraction up on top and a single fraction down below, you can flip the fraction down below, take reciprocal of it, and multiply it times the top one. So that's the other way. I like this way that I've showed because this will handle 100% of the problems. The way I just mentioned only works when you got a single fraction over a single fraction.